Okay, gang, we're going to do 7.1, and this section isn't bad at all. It's going to be calculating the area between two curves, but it's not a difficult process. You won't find this section difficult. All right, so let me just explain the process. So remember, when you integrate, it's going to find the area from the curve to the horizontal, right? So if we integrate here, we're going to get the area under this big curve. So if we integrate this top curve, we're going to get the area from the top curve down to the horizontal. If we integrate the bottom curve, we're going to get the area in between the bottom curve and the horizontal x-axis. Now, if you take this area and you subtract this area, you get the difference, which is this area, which is the one that we want, which is the area between the curves. So the concept is, or the process is that you just make sure when you set this up that you have the top function first, the higher function first, minus the lower function. So it's the top function minus the bottom function, and then the upper limit will be the right endpoint, and the lower limit will be the left endpoint. Now, sometimes the right and left endpoint are obvious because they're part of the graph, and sometimes you have to actually solve the system. You have to do the intersection like you would in intermediate algebra. You set the two functions equal, right? Because if they're touching, like if they're touching here, you would set the two functions equal to figure out what that coordinate is, right? Two unknowns, two equations, you solve for it. Yeah, so if you get stuck on any of the areas, like you can't find the upper and lower limit, let me know. So here's the formula to find the area between the curves. It's the top function minus the bottom function, and then these are your limits, okay? So we're gonna try it on this. So I would suggest when you do this, you graph them just so you sort of know what you're looking at. You just can rough sketch it. You don't have to do anything super fancy. So this is a parabola pushed up 2 units. So if I just sort of rough sketch that, let's just say it's here. I might exaggerate things a little bit because I just want to make sure you can clearly see what we're doing. All right, so this is a parabola. It's pushed up 2 units, okay? Now, this is negative x, so it's like the identity function, except it's got like a negative slope. So the identity function goes this way. This function will go downward, right? It's got a negative slope. All right, so that's the y equals negative x. Now they're saying x is equal to 0. So x is equal to 0 would actually be the y-axis. And then x is equal to 1 would be like a little bit over from the y-axis. Okay, like this. All right, so if you look at the graph, can you see the area that we're going to calculate? Can you see it? So it's going to be sitting in here, something like this. Okay, so when I solve for this, when I set up my integral, I'm going to pick the top function. I can see here the top function is the parabola. I'm going to subtract it from the bottom function. The bottom function here would be this linear case. I'm going a little crazy with the parentheses and the brackets because I want you just to make sure you're catching all the little steps. Now, in this case, the upper limit is obvious, right? Because you're cutting it at x equals to 0 and x equals to 1. So the rightmost x value is 1. That would be your b value. And your leftmost endpoint is 0. So it spans from an x value of 0 to 1. All right, let me just clean this up a little bit. This is going to end up being a positive x. I'm just also changing the order, not that you have to do that. So this is a positive x. I just put it in the middle because of the double negative. All right, and now you guys have done definite integrals, so you know how to do it. So the only new part was like the setup, and if you have to end up solving for the limits, again, you would just set the equations equal if that happens. All right, I'm integrating. All right, so that's me integrating, and now you know once you integrate, you evaluate. Let me just see if I can squeeze this in here. So first I'll plug the 1 into everything. Right, that's the upper limit, and then I would subtract the lower limit, and we can see that everything's going to be 0 here for the lower limit, but I'll just write it so I don't lose anybody who's struggling with this concept. Okay, so this is I plugged in the upper limit here, I subtracted from the lower limit. All right, so we know this whole thing's going to go to 0, so let's see what we get for this part. So this is going to be 1/3 plus 1/2 plus 2. Let me just go ahead and get an LCD, which would be 6. So this would be 2/6 plus 3/6 plus 12/6. So it's 17/6. Okay, so this area here would be 17/6 units. You can leave your answer as a as an improper fraction or a mixed number. I'm indifferent. Okay, so try the problems that I gave you. This is a setup. You just try to figure out who's the top function, who's the bottom function, and then your left and right value. Okay? And that's it. And you just plug it into the formula. So the only thing new here, because you guys already know how to integrate, you already know how to do a definite integral. The new part here is just to do make sure you have the correct setup, right? The top minus the bottom, and that you can find the limits. And again, if you get stuck, give me a holler, okay? Enjoy it. Catch you. Bye-bye.